All right, welcome back. So let's do this. Question 5 and question 6, and then we're done. So here it's saying some auto lot sells foreign and domestic cars. The table below shows the breakdown by color, foreign or and domestic, of the cars that they currently have. So imagine if you're going to buy a car at random. Let's see the probabilities of these things happening. So before we do any of this, it's really good to understand what's the total of each one, right? I think that would really help a lot. So how many red cars are there? There are 23 red cars, right? Eight of those foreign cars are red, and 15 of those domestic cars are red. That's the way you should read this table of information. How many black cars do we have? We have 14. How many silver cars do we have? We have 17. And if we add this all up, this is 7 plus 4 is 11. This is 14, 1. We have 54 cars in total. So here, how many foreign cars do we have? We have 8, 3. This should be 21. And how many domestic cars do we have? We have 15, 26, 33. Okay? Let me actually do this over here. This will be much nicer for us. Hold on, let me fix the window real quick. Okay, this is better. All right, so let's just do this again. What is this? 23, 14, 17, 21, and 33. And it's a total of 54 both ways, right? Like if I add 23, 14, and 17, I get 54. And if I add 21 and 33, I do get 54. So we have a total of 54 cars in this lot. So find the probability that the car you purchased is black. Well, how many black cars do we have? We have 14. And if there are 54 cars, so it's just 15. I'm sorry, it's just 14 out of 54. Okay. Second one, find the probability that the car you purchased is domestic. Well, how many domestic cars do we have? We have 33. So it's just 33 out of 54. Okay. Easy peasy. Let's look at the next one. Find the probability that the car purchased is silver or foreign. All right. So here we have the example of, is this mutually exclusive or not mutually exclusive? So here, are we going to be using, is this mutually exclusive or not mutually exclusive? Here, you could have a car that's silver and it's foreign. So here, we're going to use this example here. So P of silver or foreign, right, is equal to the probability of getting a silver car plus the probability of getting a foreign car minus the probability that the car is silver and foreign. Okay, so what is the probability of getting a silver car? The probability of getting a silver is 17 out of 54 plus, what's the chance of it being foreign? It's 21 out of 54. And how many of those foreign cars are silver? So how many cars do we have that are silver and foreign? It's 10. So we're going to subtract 10 out of 54. So 17 plus 21 is 28. 28 minus 10 is 18 out of 54. Okay, and you could simplify that. All right, now to this question here. So find the probability that the car purchased is black, given that it is a domestic car. Okay, to answer this question, we need to go back to our notes and we need to look at this conditional probability. If we have, let's say if we have this, right, this original conditional probability that we've had in our notes. If we look at this, we can manipulate this equation to look like this. And why will this help us here? If we have this original equation, what we could do is we could divide both sides by P of A. This cancels, and the probability of B occurring after A has already occurred is equal to this. So let's take a look at this question here. It says, find the probability that the car purchased is black, given that it is domestic. So the car you're getting is domestic. So what's the probability of domestic given, I'm sorry, what's the probability that the car is black when it first was domestic? So it would look like this. So then following this formula, we could just have P of domestic, probably domestic and black over probability of domestic. Okay, so here, what's the probability that the car is domestic and black? It's 11 out of 54. So we have 11 out of 54 on top. And what's the probability of the car being domestic? It's 33 out of 54. And if I were to divide this, I would get 11 out of 34. I'm sorry, 11 out of 33, and that's equal to 1/3. Okay. For this question, it seems a little shaky when I'm, like, right now I'm realizing I'm not explaining it very well. I'll try and explain it better in class, or I'll make another video to help further explain this problem. But this solution should be a 1/3 chance. Let's look at the next one. What I want you to do is, using this kind of setup, right? Because the first idea, you see the black will go first, and the domestic will go second. So here, find the probability that the car purchased is foreign, given that it was silver at first. So here, using this setup, it would just be probability of silver and foreign over the probability of silver. Okay. So then here, what's the probability of your car being silver and foreign? Well, let's go back to this. The probability of silver and foreign is 10 over 54 divided by, let's see, what's the probability of it being silver? It's 17 out of 54. So this is 17 over 54. And if you divide these two, you should get just 10 over 17. Okie dokie. And that is the probability for letter E. And again, I think I'm not doing that great of a job of explaining these two questions. In class, I'll do a better job. Okay? Let's move on. So the last two questions, the last question number 6 in the 3 parts. Let's take a look. If let me zoom in a little bit. It says the combination for the lock shown below consists of 3 numbers. So yeah, hopefully you've seen one of these growing up, or you have one of these locks. How many possible numbers are there? There are 40 possible numbers, right? Because you have to include 0, and it goes all the way to 39. So there are 40 possible numbers you could choose from for the first dial. So if the numbers could be repeated, how many different combinations are there? How many different numbers can I use for the first slot? It would be 40. How many can I use for the second? It would just be 40. 40. So this just is 40 cubed, which is, how much is that? 64,000 combinations, right? So this should be 64,000. Here, if the numbers cannot be repeated, how many different combinations are there? Well, the first one could be 40 combinations. Then if you used one, then you could only have 39 for the next one, and then you could only have 38 for the next one. So whatever 40 times 39 times 38 is, 40 times 39 times 38, there are 59,280 combinations. So 59,280 combinations. Or if you were you could have done this, or we could have done 40 permutation 3. So this would have been, let me just put it over here for letter B. Let me zoom out a little bit, my bad. Okay, here, remember, if I have some NPR, this is equal to n factorial over n minus r factorial, right? So this is equal to 40 factorial over 40 minus 3 factorial, and that's just equal to 40 factorial over 37 factorial, but that's just equal to 40 times 39 times 38, and that would have also worked. Okay, if we look at question 7, let's read it real quick. It's saying a fast food restaurant has the following options for the toppings of their hamburgers. You have mustard, ketchup, mayo, onions, pickles, lettuce, and tomato. So you have 1, 2, 3, 4, 5, 6, 7. We have 7 choices, and we want to choose 4 of them, right? So here, this is going to be an example of a combination. So here, this is where order doesn't matter. Whenever you have your toppings, order doesn't matter. So how do we actually solve this? If we have some, let me get the formula down real quick. This is, what is it? NCK, it's n factorial over k factorial times n minus k factorial, right? So this is just, our n here is 7. So it's 7 factorial over 4 factorial. 7 minus 3, this is, I'm sorry, 7 minus 4, that's 3 factorial. So then here, this is just equal to 7 times 6 times 5 times 4 times 3 times 2 times 1 over 4 factorial, right? So that 4 factorial goes here, right? And notice that it's just going to cancel out. And then we have that 3 factorial over here, 3 times 2 times 1. So what is 7 times 6 times 5? What is that? That's 210. And divided by 6, that should be, what is that? That is 35. Okay. So then there are 35 different possible ways you could use these. You could use 4 toppings out of the 7 for your hamburger. Okay. So for your test, you'll have something very similar to something like this, just in a different context. So you're going to have to know when to use permutation, when to use combination. When does order matter? When does order not matter? All right, I hope these videos helped. We will, of course, go over everything in class. I'll see you.